Assalamualaikum and hi everyone. So today we are going to discuss about chapter 4.4 Intermolecular Forces of Attraction. So our learning outcomes, you should be able to describe intermolecular forces, van der Waals forces, dipole-dipole interaction, London forces or dispersion forces, and hydrogen bonding. Okay, and for these two learning outcome, I am going to discuss in another video. Okay, so let us proceed to introduction. Okay, so there are two types of attractive forces. The first one is intramolecular attractive forces, and the second one is intermolecular attractive forces. So you have to understand what is the difference between these two attractive forces. Okay, so the difference is intramolecular attractive forces adalah attractive forces yang berlaku di dalam molekul. Manakala intermolecular attractive forces ni adalah attractive forces antara molekul. Okay. So in this video, what I'm going to focus on is I'm going to focus on intermolecular attractive forces, iaitu tarikan antara molekul. Okay, so why do we need to learn about intermolecular attractive forces? Because the strength of intermolecular attractive forces is responsible for the physical properties of simple molecular compound. Physical properties here, for example, adalah boiling point, melting point. Okay. So maksudnya, kalau contoh we want to determine boiling point for water and alcohol. Okay, so one of the boiling point may be slightly higher than the other one. So kenapa? Okay, the reason behind the boiling point tu adalah bergantung kepada the strength of intermolecular forces. Okay, so nanti kita akan belajar lah. Okay, and then the purpose of this diagram here adalah untuk explainkan dua benda ni. Okay, so to make you see clearly intramolecular forces tu macam mana. Okay, so bonding ini adalah molekul HCl. Okay, so in this molecule ada two atoms, iaitu H and Cl. So the bonding between hydrogen atom and chlorine atom here, the bonding here adalah intramolecular forces. Okay, and if you want to be specific, type of intramolecular forces yang exist antara H dan Cl ni, sebabkan H non-metal, Cl is also non-metal. So intramolecular forces dia adalah covalent bond. Okay, so for this one adalah covalent bond. Alright, and then for kita ada this one pula. Okay, so this one adalah ini one HCl molecule. This is another one HCl molecule. So bonding between these two HCl molecules, itulah yang kita panggil intermolecular forces. Okay, so itu yang kita nak belajar sini. Okay, so as you can see here, saya tulis strong, saya tulis weak. Okay, so from here you should be able to detect that intramolecular forces is stronger than intermolecular forces. Inilah intramolecular forces is stronger than intermolecular forces. Okay. So, apa example intramolecular forces selain pada covalent bond? So, you can see here in this table. So, example of intramolecular attractive forces are ionic bond, covalent bond, and dative bond. So, semua ni kita dah belajar. But actually, this one dia fall under intramolecular attractive forces. And today, what we are going to learn adalah intermolecular attractive forces. And the example of intermolecular attractive forces are van der Waals forces and hydrogen bonding. But for van der Waals forces can be divided into two. Ada dipole-dipole forces, ada London forces or dispersion forces. Okay, so now kamu dah tahu perbezaan apa intermolecular forces, apa intramolecular forces. So next time if I ask you, give me an example of intermolecular forces, don't give me example covalent bond ke, dative bond ke, ionic bond ke, jangan. Okay, sebab ini intramolecular attractive forces. Okay, so please give me something like van der Waals forces or hydrogen bonding. Okay. So, next kita tengok strength of intermolecular forces. Now, our focus is mainly on these intermolecular forces. So, intermolecular forces ada dipole-dipole, ada London, ada hydrogen bonding. So antara tiga ni yang mana paling kuat? So yang paling kuat adalah hydrogen bonding is the strongest among all three. Tapi yang paling lemah adalah London dispersion forces. And yang tengah-tengah yang kuat sikit daripada London dispersion forces adalah dipole-dipole forces. Okay, untuk yang pening, apa arrow ni maksud dia? Okay, so that's mean this arrow from left to right. So maksud dia adalah increasing strength of attractive forces, of intermolecular forces lah. Okay, so saya ringkaskan IMF. Okay, so let us learn about London dispersion forces. Okay, so London dispersion forces exist in all atoms or molecule. Kiranya London dispersion forces ni wujud dalam semua atom dan semua molekul yang ada dalam dunia ni. Okay, so maksudnya tak kisahlah molekul tu polar or non-polar, dia akan ada London dispersion forces. Okay, so these London dispersion forces arise because of the temporary dipole induced in molecule. Okay, so dalam molekul tu ada temporary dipole yang akan terhasil dan temporary dipole itulah yang menyebabkan adanya London dispersion forces ni. Okay, so this temporary dipole is also called as instantaneous dipole. Okay, juga dipanggil sebagai instantaneous dipole. Okay, so London dispersion forces. London ni bukan London yang dalam negeri, dalam England tu Okay, so London ni adalah nama orang. Okay, Freeze London. Freeze London 1930 cakap, when electron revolve around the nucleus, there is a possibility that at any given instant, the electron density might be higher at one end than the other. This gives rise to a temporary dipole. Okay, so maksudnya dia kata dalam atoms tu atau molekul, elektron tu sentiasa bergerak around the nucleus. So ada keadaan, ada possibility di mana at any given instant tiba-tiba je elektron density tu mungkin tinggi dekat satu kawasan and mungkin rendah dekat satu kawasan. So bila keadaan ni berlaku, itu menyebabkan adanya temporary dipole. Dipole tu maksudnya ada kawasan yang partially negatif, ada kawasan yang partially positif. So example macam ni lah, I always draw kat kamu hari tu, saya pernah draw macam ni kan. So let's say area ni banyak elektron. So this area akan jadi partially negatif and this area kurang elektron, so dia jadi partially positif. Okay, so bila ada unequal distribution of electron ni, inilah yang menyebabkan adanya temporary dipole. Okay, so nak faham lagi apa maksud Freeze London ni, kita kena faham how London dispersion forces is formed. Okay, so let us look at this diagram here. Okay, so yang bulat-bulat ni adalah molekul atoms lah. Okay, so sebabnya kamu kena faham dalam satu solution, tak kisahlah solution tu apa pun, dalam ni ada banyak molecules and attraction between molecule tu, itulah yang kita nak discuss hari ni. Okay, about London dispersion forces. Okay, so dia kata an atom has a positively charged proton in its nucleus and the negatively charged electrons surrounding the nucleus. Ini biasalah. We know that at the central atom yang positive charge ni adalah nucleus. And all the dash here adalah elektron sebenarnya yang saya nak maksudkan. Okay. And the second point, on average, the negative charge of the electrons in the atom is spread evenly around the nucleus. So, kayaknya dalam keadaan yang normal. Okay. Negative charge ni spread evenly. Spread evenly tu macam kedudukan dia macam sama rata je. Jadi, tak ada kawasan yang kaya elektron, tak ada kawasan yang kurang elektron. Macam ni lah. Okay. Spread evenly around the nucleus. Tapi, kita tengok the next one. At any instant, one side of the molecule has higher electron density than the other side. Okay? That means, elektron tu kan dia boleh bergerak. So, bila elektron tu bergerak, elektron tu mungkin tiba-tiba dia ramai-ramai elektron, banyak-banyak elektron tu bergerak ke sebelah kanan. So, end up, area sebelah kanan ni become, electron density dia makin tinggi. And area sebelah kiri, electron density kurang. So, area yang electron density tinggi, kita akan cakap dia partially negative. While the other side, since kurang elektron, so dia jadi partially positive. So, sekarang you can see ada partially negative, ada partially positive. Maksudnya di sini kita ada temporary dipole or instantaneous dipole. Okay. So, kita sambung lagi baca bawah. Dia kata, at this instant, the atoms or molecule become a small instantaneous dipole. Okay, so maksudnya inilah. Ini, this one, you can label this one as instantaneous dipole. Ataupun kadang-kadang kita guna perkataan temporary dipole. Okay, so pergerakan elektron tadi tak sekata. Area ni kaya elektron, so dia jadi partially negative, partially positive. So ini molekul ni sekarang ada instantaneous dipole or temporary dipole. Then induce a dipole on the neighboring atom. So this instantaneous dipole or temporary dipole will induce this molecule untuk jadi macam dia juga, untuk ada dipole macam dia juga. So macam mana dia nak induce this molecule untuk jadi macam dia juga? Okay, so kita baca bawah ni. Due to electron repulsion, a temporary dipole on one atom can induce a similar dipole on the neighboring atom. Okay, kita stop situ dulu. So, maksudnya, macam mana this instantaneous dipole induce another dipole adalah dengan guna electron repulsion. Okay, so kita fikir dekat sini. This area now kaya electron. Okay, so partially negative. And somehow, sini pun ada banyak elektron. So, elektron and elektron, kita dah memang tahu. Elektron versus elektron, dia memang akan sentiasa repel each other. Dia akan tolak satu sama lain. This electron will repel this electron. Okay. So, bila elektron dekat sini repel this electron, so this electron tertolak ke sebelah kanan. Okay. So, elektron ni pun tertolak ke sebelah kanan. So, bila dia tertolak sebelah kanan, so dia jadi macam mana? So, dia jadi macam bawah ni lah. So, as you can see, area ni disebabkan elektron ni repel this electron here, so kurang elektron sini. And all, not all lah, most of the electron dah pergi ke kanan. That's mean, this instantaneous dipole dah berjaya induce this atom to become macam dia juga. Jadi ada dipole juga. Okay. So macam mana pula attraction tu berlaku? Okay, so kita sambung. Dia kata, due to electron repulsion, a temporary dipole on one atom can induce a similar dipole on neighboring atom, which can cause the neighboring atom to be attracted to one another. Okay, so from here you can see, ini area negatif, ini area positif. Negatif positif akan berlaku attraction. So, ada attraction dekat sini. And this attraction here adalah London dispersion forces. Okay. Alright. So, that is how London dispersion forces berlaku. So, this interaction is called London dispersion forces or just dispersion forces, and only significant when the atoms are very close to one another. Okay, maksudnya ialah kalau dah atom ni jauh-jauh ataupun molekul tu jauh-jauh, macam mana this elektron nak repel elektron yang dalam molekul lagi satu kan? Okay, so repulsion tu berlaku bila elektron-elektron tu dekat-dekat, so they will repel each other, and up one side akan jadi kaya elektron, one side kurang elektron. So, partially negative, partially positive will attract. And this one, dia akan keep on berlaku sebab dalam tu kan ada molekul banyak. Okay, ada molekul lagi, ada molekul lagi. So, benda tu akan berterusan. Okay, so berlakulah London dispersion forces. Okay, so next we want to learn about dipole-dipole forces. Kita nak belajar pasal dipole-dipole forces. Okay, so for dipole-dipole forces, exist between polar molecule only. Okay, so kalau molekul tu polar, baru ada dipole-dipole forces. Kalau non-polar, dia tak ada dipole-dipole forces. Okey, sebab apa? Sebab polar molecule contain permanent dipole. Permanent dipole maksudnya dia ada dipole yang tetap. Okey, so for example yang saya selalu bagi HCl. Okey, kita tahu H dengan Cl, Cl is more electronegative. So, area Cl is partially negative, area hydrogen is partially positive. And this one, dia tak akan berubah. Okey, memang dia tak akan berubah. Dia memang always Cl partially negative. Sebab Cl more electronegative, so Cl akan tarik banyak elektron ke arah dia. So, H plus kurang elektron, so dia jadi area yang delta positif. So, this dipole takkan berubah. That's why dia panggil permanent dipole. Berbeza dengan tadi. Okay, so arise from the attraction between the positive end of one molecule and the negative end of another molecule. Okay. So, kita boleh tengok bawah ni lah yang paling senang. Okay, so you can just refer to this diagram. So, in this diagram, ada HCl molecule, and another HCl molecule. So, H dengan Cl, H is partially positive, Cl is partially negative. So, this HCl molecule sama juga. H partially positive, Cl partially negative. So, negative and positive here, they will attract each other. So, attraction that occur here, inilah yang kita panggil dipole-dipole forces. Okay, so ini Cl negative dengan H positive pun ada dipole-dipole forces. So, as you can see, this one is easier sebab dia dah memang ada dipole dia dah. Okay, so we don't have to induce dipole whatsoever, dah tak perlu. Okay, so the strength of dipole-dipole forces increase with the increase in polarity of the molecule. A more polar molecule will have stronger dipole-dipole interaction. So, kiranya kekuatan strength of dipole-dipole forces ni bergantung kepada polarity. And for polarity, polarity depends on electronegativity lah. Okay. So, kiranya kalau kita ada HCl versus dengan HF. So, which one is more polar? Okay. So, sepatutnya HF is more polar. Then, this one. Ini less polar. So, kenapa dia more polar? Sebab between fluorine versus chlorine. Okay. So, fluorine more ataupun high electronegativity. Okay. While Cl low electronegativity. Okay. So, itulah cara dia. Okay. So, lagi polar, lagi kuat dia punya dipole-dipole interaction ni. Okay. So, done for dipole-dipole forces and London dispersion forces. Okay, so let's try this one. Okay, so state the types of intermolecular forces that exist between each of the following molecule. Okay, kamu dah faham intermolecular forces, ada apa, van der Waals forces tu kamu dah faham, ada dua, London dispersion and dipole-dipole forces. So now what you need to do adalah, kalau kamu diberi satu molekul, kamu kena tahu molekul tu ada apa, London dispersion forces ke dipole-dipole forces. Okay. So, sini saya bagi tips how to determine intermolecular forces of a molecule. Okay, nak determine intermolecular forces, first kamu kena tengok polarity of molecule. Okay, so polarity of molecule, that means sama ada molecule tu polar or molecule tu non-polar. Okay, so if the molecule is polar, that means dia akan ada dipole-dipole forces. Okay, sebab dipole-dipole forces untuk polar molecule only. And tadi kita ada belajar about London dispersion forces kan? London dispersion forces exist in all atoms or molecule. That means untuk polar molecule dia ada dipole-dipole forces dan ada London dispersion forces. Okay, ada dua lah, tapi yang lebih signifikan adalah dipole-dipole forces. Kalau soalan objektif minta, just give one answer. Okay, and then non-polar pula. Okay, kalau non-polar molecule, obviously dia takkan ada dipole-dipole forces. Tidak akan ada. Okay, the only attractive forces that exist between non-polar molecule adalah London dispersion forces. So kita pun rule out dekat sini. Kalau non-polar molecule, that means the only attractive forces adalah London dispersion forces. Okay, so once kamu boleh hafal ini, kamu boleh jawab soalan lah. Tapi dengan syarat kena cekap yang depan ni. Okay, so let us try with HBr. Okay, so first we need to determine the polarity of molecule. To determine polarity of molecule, kita kena tahu shape dia lah. Okay, HBr simple je, Lewis structure dia macam ni. Okay, shape dia memang macam ni je lah. Alright, between H and Br, Br is more electronegative. So, we need to draw the bond dipole. Okay, so bond dipole ni cannot be cancelled out. Okay, so mu not equal to 0. So, kalau mu not equal to 0, that means HBr is a polar molecule. Okay, so kalau dia polar molecule, maksudnya type of intermolecular forces that exist between HBr adalah dipole-dipole forces. Okay, and don't forget London dispersion forces. Okay, sebab London dispersion forces ni wujud dalam semua benda. Okay, tapi kalau soalan objektif tanya bonding yang exist between HBr, you should circle dipole-dipole forces. Okay, jangan bulatkan London dispersion forces sebab itu wujud dalam semua benda. Okay, alright, and then for SO2 pula. Okay, so for SO2 sama juga. We need to start with the polarity. Tapi kita kena draw Lewis structure dan draw dalam geometri yang betul. So SO2, the Lewis structure, molecular geometry dia should look like this. S ada one lone pair, double bond, and the shape dia adalah V shape. Okay, so bonding between S dengan O more electronegative. So arrow semua pointing towards O. Okay, so as a result, you can see that the resultant dipole moment pointing ke bawah. Okay, and this resultant dipole moment cannot be cancel out sebab tak ada yang atas. So maksudnya mu not equal to 0. So in this molecule SO2 is a polar molecule, and then since dia polar molecule, that means type of intermolecular forces yang wujud di antara SO2 dengan another SO2 adalah dipole-dipole forces and London dispersion forces. Sama macam yang atas jugalah. Right. And then next one, kita nak tengok CH4 pula. Okay, so the shape of CH4, looks like this. Okay, so next kita nak determine CH4 is polar or non-polar. Okay, so CH4, bonding between C and H, C is more electronegative. Okay, and another shortcut adalah CH4 is a tetrahedral shape. All the terminal atoms are the same. That means this one, dia adalah bond dipole dia can be cancel out. So mu equal to 0. So mu equal to 0, that means CH4 is a non-polar molecule. Okay, so since dia non-polar molecule, that means the only possible attraction between CH4 and CH4 adalah London dispersion forces. Okay, so done. Alright, so I think that's all for this video. Thank you, bye.